Hello again. This is related to the video about Acasom and the test I did with the antenna up in the attic. Now let's open it up, take a look inside, see and understand how's the schematic running in this amplifier. Alright, I have my microscope hooked. Let's give it a try. Let's start with the input. This is the antenna input here. It's going to this circuit here, and this one, it's that electronic relay, let's call it, making the transfer from RX to TX, or the commutation from RX to TX. Then few parts, capacitors, another capacitors, and we are getting into this guy. This is a specialized chip, a low noise amplifier, and this is a 12 RE3S, the low noise amplifier. So this is the main RX responsible for the signal and the noise and everything, and eventually some more capacitors and some coils probably. And here we are. This is a SAW filter. The filter, as you can see, it's at the output of the low noise amplifier. Okay, so we got nothing here. That means, the signal can be very easy overload or distortion or override the low noise amplifier. This amplifier now, it's in a 10 dB configuration for RX and 0 dB for TX. You know why? Because here we have an attenuator. You see the signal comes out from the SAW filter. You have this trace here, you can see it, and then goes in the attenuator and eventually going out. This is the trace to another circuit, commuting circuit, and of course out coming through this zero resistance capacitor, the output capacitor. So this can be really an easy modified for a bias T I showed you before. Okay, this is the commuting circuit. Also, we have this buck converter, DC to DC converter. This one, it turns down from 12 volts to 5 volts necessary for all the other parts. The point is that sometimes these buck converters are pretty noisy too. Finally, we have the SAW filter after the amplifier. This is for RX. The other side, TX part, it's much better equipped. This is a specialized circuit here, AKA0110 something, and the SAW filter before. But anyway, we don't care about this because we are not talking about TX here, so we are talking about RX. So this is the main responsible for amplification and noise and everything. Should, after my opinion, maybe we should have a SAW filter before, here somewhere. But anyway, now it's too late. That's the way it is, and that's all. Maybe Acasom consider this circuit good enough to, to support high gains and not distorting the signal easy. Okay, so that's the idea of the things. That's how Acasom it's looking inside. So now, like I said, it's in 10 dB RX amplification. That's all with the microscope. First, a little update, last 24 hours. Let me see. I got 3 registered witnesses. That's not bad if you consider the actual state of the network. Beacon analysis I got from yesterday, so that means that little amplifier it's working, but unluckily just 3 beacons registered like witnessed. Okay, now I have two Acasom amplifiers here. This is brand new, same model, PA08011S, and I modify one for better reception. I mean for 17X. Let me see. Yes, both of them are on 10X. I need that before starting all the testings again. Okay, let me see. Yes, both of them are 10 RX0TX. So we need to take those resistors off and to have a strap. So what I have to do is to take these resistors here out of the picture. Yeah, they are gone. And to have a strap right here. Okay, and we'll do a piece of wire from here to here, and we have to take out this capacitor too, and it's done. And now all we have to do is to have a piece of wire there. That's and it's done. Okay, let's check that. Perfect. Okay, so this is the output from the filter going through this, and we have to, yeah, this is perfect. And this one here is the ground, of course. Yeah, super. This is a 17 RX6 TX. Let's put some labels to be sure. And 6, and the other guy it's untouched, and it's 10 to 0. Okay,